This is another video for equation practice. This is the conservation of linear momentum. Now momentum, just to start with, momentum is obviously mass times velocity, okay? And these types of questions, you might be just wanting some practice and you can just get straight into it, or you might need me to map out the first one, show you how to do it, and then let you have a go at the following three questions. So momentum is mass times velocity, and I'm gonna have a go at this one, show you how to do it, and then we've got some more practice to do as well. So these are quite tricky, so these are probably, higher ability, especially the questions where we've got to find an unknown mass. Anyway, let's begin. So if you want to pause and have a go at this one, and then I'll take you through the answer, and I'll show you how to set it up as well. So in this instance, we've got a car of mass, so it's got 938 kilograms. It's traveling to the right with a velocity of 15.1 meters per second. It collides with a van that's got a mass of 1,230 kilograms, and that's moving to the left. So that's important, because what we've got to do, because its momentum is pick a direction as positive, and then obviously the other direction will be negative. And the van has got a velocity of 3.7 meters per second. The car and van collide and stick together. So taking left as negative and right as positive, what is the velocity of the car and van after the collision? So I'm going to show you how we set this up. So I would advise that you set a table up. And because of the conservation of linear momentum, we can say that the momentum before the collision is equal to the momentum after the collision. Okay, now down the middle, that's where our equal signs go. So I'm going to show you how I do this. So we've got a car of mass 938 kilograms, so 938 kilograms, and it's moving to the right, so it's positive, and it's got a velocity of 15.1, so the momentum would be 938 times 15.1. So I'm just going to bracket that, I'll calculate that later. And it collides with a van of mass 1,230 kilograms, but that's moving to the left. So that's going to have negative momentum. So we're going to minus the 1,230 kilograms times 3.7. So that's before the collision. We've done the momentum of both vehicles before the collision, so that's done. And that's going to be equal to the momentum after. Now, what these do is they stick together, so we need to add the masses. So we need to do 1,230 plus 938. So that gives a combined mass of 2,168. And what we've got is some unknown velocity, so it's times v. And then all we need to do is do a bit of maths and rearrange to find the velocity. So we need to do 938 times 15.1. which is 14,163.8. I'm going to say plus then, but it's minus the 1230 times 3.7. So that's 4,551 equals 2,168 lots of v. So we need to do the 14,163.8 minus 4,551. So that gives us 9,612.8 equals 2,168 times the unknown velocity v. So to get v, we simply need to get rid of the times 2,168 by dividing on the other side. So that's 9612.8 divided by 2,168, and that will give us v. So v is equal to 4.4 meters per second. The value is positive, so it's going to the right. Hopefully that's okay. Right, let's try a different example. So if you want to pause and have a go at this one, and then I'll take you through the answers, see if you get it right. So on this one, we've got a car of mass m1, so we don't know what the mass is for the original car. It's travelling to the right with a velocity, so right's positive, with a velocity of 19 meters per second. It collides with a van, and that's got a mass of 1,100 kilograms moving to the left, and that has a velocity of 5.31 meters per second. So the car and the van collide and stick together, and they move to the right, moving to the right, with a velocity of 4.77 meters per second, and we need the mass of the car. So it's the exact same setup as last time. So I'm going to draw a table. And what we can say is that the momentum before is equal to the momentum after the collision. So momentum after. That's just the conservation of linear momentum. Okay, so let's look at this one. So we've got a car of mass, unknown mass m, and it's moving at 19 meters per second. So normally we do mass times velocity, so we're going to do m times 19. So that's going to be 19 lots of m. And then we've got a van moving in the opposite direction, moving to the left. So we're going to subtract. We've got the mass of 1,100 times 5.31. We'll deal with that in a moment. I'll just bracket that off. So that's before the collision equals after the collision. We've got to add the masses. So that's going to be the unknown mass plus 1,100. Then we're going to multiply that by the final velocity, which is 4.77 times 4.77. Then all we need to do is to do some maths and, multiply out a bracket and find m. So I'm going to do that now. So first of all, let's do the 1100 times 5.31. So 1100 times 5.31 would be 5841. So I've got 19m minus 5,841 equals, and then let's multiply out this bracket. So I've got 4.77 times m. So I've got 4.77 lots of m. Plus, and then we're going to do 4.77 times 1,100, which gives us 5,247. Right, then what we need to do is get anything with a m on the left-hand side and then the numbers on the right-hand side. So we need to do 19m plus, I'll tell you what, I'll actually do another line on this working out. So 19m minus 4.77 lots of m equals, and then on the other side we've got 5,247. And then we need to add, so we've got minus 5841 on the left hand side, we need to add 5841 on the right hand side. Then we need to do 19 minus 4.77, which is 14.23. So 14.23 lots of m equals, and then add these two numbers together, which is 11,088. And then to get the mass, we simply need to divide through by 14.23. So it's 11,088 divided by 14.23. So that gives us a mass that's equal to 779 kilograms. I would anticipate that that's quite a high level question. That's a top end calculation that you could get in the back end of a GCSE exam paper. If you got it right first time, then that's excellent. If you followed that and that's fine now, that's great. I've got another two examples that we can do, and one of them is quite similar, so you get a little bit more practice. So let's do another question. So if you want to pause the video and have a go at this one. Okay, so let's make a table. And that would be momentum before. I'm just going to write before. The momentum before is equal to the momentum after. So let's have a look at this one. So we've got a car with all the mass, 830 kilograms, moving to the right with an unknown velocity v1. And it collides with a van of mass 1,210, moving to the right. So this time it's moving in the same direction, 5.1 meters per second. The car and van collide and stick together, and they still move to the right, obviously, with a velocity of 13.5. What is the initial speed of the car? Pretty fast by the sound of things. So anyway, let's do, conservation of linear momentum. So the momentum of the car would be mass times velocity. So we've got 830 times v. Plus we've got the momentum of the van. So that's 1,210 bracket times 5.1. We'll deal with that in a moment. So that's before the collision equals after. So we need the total mass because they're going to stick together. So we've got the 1210 plus the 830. Which gives a combined total mass of 2,040 kilograms, and they're moving with velocity 13.5 meters per second. So all we need to do now is do a bit of maths and make v the subject. So let's have a look at that. So we've got 830 lots of v plus, so we can do 1,210 times 5.1, which gives us 6,171, so 6,171 equals, and on the right hand side we've got 2,040 times 13.5, which is 27,540. So what we need to do, we need to get 830 lots of V equals, we're going to take the plus 6171 to the right hand side where it becomes negative. So we need to do 27,540 minus 6,171, which gives us 21,369. Therefore, V would be equal to 21,369 divided by 830. And that gives us an initial velocity of 25.7 or 26 meters per second. Could do three significant figures actually, because that's what's given in the question. 25.7 meters per second. Relatively quick. If you got that, really well done. And let's do one more. Okay, so if you want to pause and have a go at this one, and then I'll take you through the answer. So car this time, similar to the second question, unknown mass, travelling to the right with a velocity of 23.1. Collides with a van, which has got a mass of 1,010, and that's moving to the left this time. And that's got a velocity of, it's been minus 6.04 meters per second. The car and van collide, stick together as they normally do at GCSE, and move to the right with a velocity of 4.31. What is the mass of the car? So if you did number 2 properly, and you followed that one, this one should be okay. So let's just have a check. So momentum before the collision is equal to the momentum after the collision. That's just the conservation of linear momentum. Okay, let's have a look at this one. So I've got a car mass m1 travelling to the right with velocity 23.1. So I'm going to say mass times velocity is 23.1 lots of m. I'm going to add that to the van. In fact, we're going to subtract it because the van is moving in the opposite direction. So minus 1,010 times the velocity of the van, which is 6.04. Deal with that in a moment. Equal to, so afterwards the van and the car collide and stick together. So we need to combine the masses. So we've got the unknown mass m plus 1,010, bracket that, times their velocity moving to the right of 4.31. Okay, so let's do a couple of calculations. So I've got 23.1 lots of m minus, so you got 1,010 times 6.04, which is 6,100.4. Equals, and then let's multiply this out. So we've got 4.31 lots of m plus, we need to do 4.31 times 1,010, which is 4,353.1. So let's get the m's on the left hand side and the numbers on the right hand side. So 23.1 m minus 4.31 m equals, on the right hand side we've got 4,353.1. and on the left hand side it's a negative, so we need to add the 6,100.4. So 23.1 minus 4.31 gives us 18.79 lots of m equals, add these two numbers together, which gives us 10,453.5. So the unknown mass is simply the 10,453.5 divided by 18.79, which gives us the unknown mass, which is equal to 556 kilograms, which is exceptionally light for a car, and that's lighter than F1, but never mind. Hopefully you found that helpful. Those questions can be quite challenging at GCSE. If you want to redo them, obviously feel free to rewind and try again. Thanks for watching, and I'll speak to you soon.